Hello class, today we're going to be talking about 9-3 transformations of quadratic functions. And basically what we're going to be looking at is how the equation changes the way our parabola looks. Or we can look at a parabola and determine what the equation is going to be. And so with these translations, follow along with me and fill in the blanks. A translation is a change in the position of a figure either up, down, left, right, or diagonally. And then we're going to be adding and subtracting constants in the equations of functions translates the graphs of the functions. And so the first one we're going to look at is the graph of g of x equals x squared plus k, and how that changes the function f of x equals x squared. And so when we add the k, it's going to change our graph vertically. So in this case, we're dealing with k. That's the focus on this one. So if k is greater than 0, we know that our parabola is going to be translated k units up. Whereas if k is less than 0, then we know that our graph, the function of f of x equals x squared, it's going to be translated k units down. So that's just the first one we're going to look at. The next one, we have the graph of g of x equals x minus h in parentheses squared, and how that changes x squared is horizontally. So in this case, we're looking at minus h. So if h is greater than 0, then we know that it's going to be translated h units to the right. And if h is less than 0, we know that our parabola, our function f of x equals x squared, is going to be translated h units to the left. Okay. And this will make more sense when we go through some examples. Kind of just throwing a bunch of numbers at y'all. So if we look down here at the first one, we have x squared plus 4. So this kind of goes with the one we have up here, x squared plus k. So we know k in this case is 4. And 4 we know is greater than 0, so we know that our parabola is going to be translated up 4 units. So here's our original one, f of x, and our new function, g of x. It's the same exact thing, it's just translated up 4 units. So we can put off to the side, translated up 4 units. And that's the only thing that changed on that one. Now we look at the next one. We have g of x equals x plus 3 squared. Now this is where we're going to look at h. See how here we have minus h, and here it's plus h? So we know in this case h is going to be less than 0 because the two negatives created the positive. So here we have h is minus 3, negative 3. So x minus negative 3 is going to give us the x plus 3 in this case. So we're looking here. H is less than 0. In this case we have negative 3. So it's going to be translated 3, because we have the absolute value, 3 units to the left. And so we can look at our original function, f of x, and you see that's translated to the left 3 units. Another way I like to think about this, what does x have to equal in order for this to be 0? And this kind of ties back to what we've been doing. So if x is negative 3, we get a 0 right here, and that's why you have it on the x-axis, y equals 0. Okay, so we're going to go ahead and look at a couple of the examples at the bottom. We're going to do number 1, 2, and 3 together, and then I'm going to have y'all try 4, 5, and 6 on your own. So the first one, we have g of x equals x squared plus 1. And we want to determine how this function changed from the original f of x equals x squared. So if we're describing the change, we're just adding 1 at the end. So we're going to come back to the top, where we have k is greater than 0. We're adding 1. So since it's greater than 0, we're going to translate this parabola up, and we're only going to translate up 1 unit. So if we're describing what happened, we're just going to put translated up 1 unit. And that's it for that one. Then we look at number 2. we have x minus 6 squared. And so we look back here and see how we have the minus, and so we have h equals 6. So when h is greater than 0, h is going to be translated, it's our function f of x equals x squared is going to be translated 6 units to the right. So we're just going to write translated right 6 units. And then we're going to look at this last one, number 3, together. So we have x plus 1 squared. So x plus 1. And it's important to pay attention to the parentheses to help us understand that we're looking here and not up here. So since we're squaring this whole thing, we have to figure out what is h. Well, since it's minus h, we know that h is going to be negative 1. And when h is less than 0, we get that the function f of x squared is translated 1 unit to the left. And so that's the only ones we're going to do on this page. What I want y'all to do is go ahead and attempt number 4, 5, and 6. Okay, so in the first part we looked at translations moving up and down and left and right. Here we're going to be looking at dilations and reflections. And a dilation is a transformation that makes the graph narrower or wider. And then the parent graph. A reflection flips over the x and y axis. The x or y axis. And so the first one we're going to be looking at is the dilations. And when we have a dilation, you'll have an f of x equals ax. So we have a constant out in front of our x squared. And so the two types of dilations we said are narrow or wider. And we're going to call those stretches or compresses. It either stretches or compresses. So the graph of f of x equals x squared if a, the absolute value of a, is greater than 1, the graph f of x equals x squared is stretched vertically. It's going to be more narrow. And if a, the absolute value of a is between 0 and 1, and typically they'll give it to us as a fraction, just to make a little note off to the side, the graph f of x equals x squared is going to be compressed. It's going to become wider, so compressed. And so we're also going to look at to where we have a reflection. And so we have the graph of the function negative f of x flips over the graph f of x equals x squared across the x-axis. And so typically if it just changes to where we have a negative sign out in front, then you'll know that it just reflected across the x-axis. And that's typically whenever you have like the U shape or the N shape, we know that there's a negative out in front. We know that it's going to be in the shape of an N. And so we have the graph of the function f of negative x flips the graph across the y-axis. And these are going to make more sense when we start going over some examples as well. So we're going to look at this first one. We have g of x equals 2x squared, and how did it change from x squared to 2x squared? So we have our original function f of x equals x squared, and you notice how we have the 2x squared on the inside. Because remember, if we go up here, if the absolute value of a is greater than 1, it's going to stretch. It's going to stretch vertically, so it's going to be moving up at a higher rate, making our parabola narrower. And so we can write 2 is greater than 1, so it's going to stretch vertically. And you can also write narrower or something like that. And so now we're going to look at this other example over here. G of x equals negative 1/2 x squared minus 3. Now we have a whole lot of things going on in this one. The subtraction sign out in front tells us that it's going to reflect across the x-axis. So we know it's already going to reflect across the x-axis. Let's write that down. And then we look at the 1/2. Well, 1/2 is between 0 and 1, and so we know that it's going to be compressed vertically. It's going to become wider. So we can say compressed vertically. And then we also have this -3 out at the end. And that's kind of back to what we did on the first page of notes. The -3 tells us it translates down 3. So there's a whole lot of things going on in this one, kind of tying everything together. Translate 3 units down. And so when we look at it, here's our original f of x. It reflected across. It's also translated down 3 units. And you can also see how this one's a little bit wider than the one we have up here. So hopefully this is all starting to make a little bit more sense. Just to kind of recap, if a is greater than 1, the absolute value of a is greater than 1, we know our parabola is going to be more narrow and it's going to stretch vertically. Whereas if it's between 0 and 1, where we're given a fraction for the most part, it's going to be wider and it's going to be compressed vertically. And then if we have a negative f of x, so we have a negative out in front, pretty much just going to flip across the x-axis to where it's an n, or if it wasn't n, it's now a u shape. And then we have the graph f of x, negative x, to where the x changes sign, and it pretty much just flips across the y-axis. Okay, so we're going to look at the first 3 together. So we have number 7 is g of x equals negative 5x squared. So how does it change from x squared? Well, the negative out in front tells us that it's going to reflect over the x-axis. So we can go ahead and say reflect over x-axis. And the 5, it's greater than the absolute value of 1. So we know that it's going to be more narrow and it's going to stretch vertically. So pretty much it's just reflecting across, and it's going to be more narrow and it's going to be stretched vertically. Then we look at 8, and this one gets pretty tricky. We have the negative out in front, so we know that it's going to reflect across the x-axis. And so reflect across the x-axis. And then we have x plus 1. Now remember, if we go back to the first page, we had x minus h, and in this case we have plus 1. So we know h has to be negative 1, and if h was negative, we know that it's going to translate left 1 unit. And like I said before, the way I like to think about it, what does x have to be in order to make this part 0? Well, x has to be negative 1, so we know that we're going to move to the left. And that's just the way I think about it. And so that's it for number 8. We know the negative out front tells us it's going to reflect across the x-axis, and then the x plus 1 inside parentheses with the x with the squared, it's going to translate it left 1 unit. And so now we look at number 9. We have negative 1/4 x squared minus 1. This kind of ties a lot of the stuff in together. The negative out in front tells us to reflect across the x-axis. The 1/4 is between 0 and 1. Bring that back up for you. If a is between 0 and 1, the absolute value of a, then we know it's going to be compressed vertically and it's become wider. So we come back. We know it's going to be compressed vertically, or become wider, if that's the way you think about it. So now we've looked at this part. We have the x squared minus 1. And so that's just going to be the translation, that it's going to translate down 1 unit. And that is all. So what I want y'all to do is go ahead and give it a try on problems 10, 11, and 12. And I know this is a lot, but just work with us and we'll get it down. And if you have any questions, we'll try to clear those up in class. Just go ahead and solve the 6 problems for this video and submit it through Edmodo.